So it is a problem related to collision. So before collision, it is said that this particle is not moving, so the velocity is zero. What is the total momentum of the block just after collision? So in any collision, conservation of momentum is applicable. It doesn't matter what type of collision it is, right? So we have studied two types of collisions, inelastic and elastic, and the elastic we have perfectly elastic and elastic collisions. But for any type of collision, conservation of momentum is applicable. So conservation of momentum says that whatever we have initially should be there finally as well. So as long as we know the initial momentum, we know that the final momentum or after collision momentum is also the same as the initial one. So in the case of the initial momentum, we only have one particle that is moving. So it is m1 v1, and the other particle, it is going to be 0. So it is 8 times 4, which is 32 kilogram meters per second. Right. If the collision were elastic, what is the total kinetic energy of the block just after the collision? So the difference between elastic collision and inelastic collision is, in an inelastic collision, right, the particles travel as a single unit. So before collision is this, after collision it is going to travel as a single unit. So the velocity after the collision would be same for both the particles. But for an elastic collision, what is going to happen is both of them will travel as individual objects. So if the before collision is something like this, after collision is also something like this. So in this case, it is an elastic collision. It is said that it is an elastic collision. But as we learned, elastic collision has two types of elastic collision. So one, we call it perfectly elastic collision, and the other one is just elastic collision. But in North American system, the elastic collision is what you all refer as the perfectly elastic collision now in whatever the syllabus that you're studying at this level, the high school level. Elastic collision itself is treated as perfectly elastic collision, right? So this term, you should understand, it is for perfectly elastic collision. So what is the difference between the perfectly elastic collision and a normal elastic collision is that in perfectly elastic collision, the kinetic energy is conserved in addition to the momentum, right? So here, the kinetic energy is conserved. But in an elastic collision, kinetic energy is not conserved, right? However, the conservation of momentum is applicable for elastic collision and inelastic collision. Don't worry about that, right? But the kinetic energy is conserved. So as long as we know the initial kinetic energy, we can find the final kinetic energy because it is a perfectly elastic collision, right? So what is the initial kinetic energy, or what is the kinetic energy equation? So the kinetic energy is given by half mv squared. And we only have one particle moving at the moment, or initially. So the second one, it is going to be 0. So the mass of the first particle is 4. Velocity is 8. So it is going to be 168, right? So joules. So 64 times 2. Sorry, 128, my God. 128. Okay. Any questions?